All right. So the first problem is an exponential equation. So what did we do? What did we do on the exponentials yesterday? Yeah, but we have to do what to both sides? Take the log of both sides, right? So remember, exponential problems, we take the log of both sides. The logarithmic problems, we rewrite as exponentials, right? So if you remember that, it makes it really easy to do. So we just take log, and it's common log. If you wanted to, you could use natural log, but, oops, I gotta put log here. All right, now, from our rule of logarithms, our properties, what can we do with those exponents of the 5, 12, and 1/8? Move them to the front. Get them out of the exponent level and put them on the main level or the ground level of the equation, okay? So that's why we do that. So we can move that 5x minus 1 on the same level as everything else. Okay? Now I got to move one of the logs over. Okay? I always like to move the one on the left over to the right, but if you decided to move the one on the right over to the left, you're not wrong. It's okay. All right? But just trying to keep everything the same, I always go the log on the left over to the one on the right. And I'm going to get an answer here that I'm going to have to distribute then through that negative 4 minus x. Any questions so far? All right, so I'm going to hit log of 1/8. Remember to close it up, divided by log of 5/12. We get negative 0.3 repeating. What is that as a fraction? Yeah, negative 1/3. I like to write those as a fraction. So that's here. Okay, now I have to distribute this. This answer here. Okay, so it's 5x minus 1. Negative 4 times negative 1/3 is a positive 4/3. And negative 1 times a negative 1/3 is a positive 1/3 x. So now my equations looks like that. All right, so I have an x on each side. I want to get the x's together. So I'm going to take the 1/3 x and subtract it over to the left side. So the x's are together. And I'm going to take the 1 over to the 4/3. So I'm basically doing two things at once here. All right, so 5 is 15/3, right? 5 times 3. So since it's 1/3, I'm going to change 5 to 15/3, so I have the same denominator. What's 15/3 minus 1/3? 14/3. So that's on the left, okay? And I'm going to change 1 to 3/3. So what's 4/3 plus 3/3? 7/3. Okay? So I just changed 5 to thirds and 1 to thirds, so I have common denominators. So I could do the addition and the subtraction. You with me? Now, what do I do with that 14/3? Divided. But what's better? Multiply by the reciprocal, right? So multiply both sides by 3/14. That's a pretty easy problem. Okay, so that gives me x. What happens to these 3's? They'll cancel. How many times does 7 go into 7? Once. How many times does 7 go into 14? Twice. So the answer is 1/2. So again, we take the logs, both sides, so we can move those exponents from the exponent area down to the main level. Put it out front from our rule of logarithms there and exponents. Okay, and then just do the math. Once you get it here, once you get it to here, it's just your basic equation and following your rules that you all know how to do. Right? Do to what? Like, why don't you grab these? Good job. You forgot to do your job. All right. Questions on any part of that? Vince, you with us? I know Taylor was helping you. You look like you're kind of lost right now. I want to help you if you need help.
It wasn't loaded, everything did for the point. I don't know. The way you did it, I was doing
I like to do it in the fraction form. Yeah. If it was like a 0.5, if it wasn't that repeating decimal, I could probably stick with the 0.5. You know, if it's a decimal that stops. But if it's repeating, I'd rather use the fraction than you don't get. Because sometimes we'll just, for 0.3 repeating, a lot of times we'll just use 0.3, and that turns it into some mistakes there. Okay? That little bit of difference. All right. Number 22 was the other one I asked you to do. Okay? So all we need to do is rewrite that in exponential form. What's the base? 3. What's the exponent? 2. And what's it equal? 2x plus 1. So that's all we're doing, is rewriting it exponentially. Well, we know what 3 squared is. What is it? 9. And then just solve. So we get 4. We're supposed to check these, all right? What's 2 times 4? 8 plus 1, 9. Is 3 squared 9? Yeah. Or if I do log of 9 divided by log of 3, I'll get 2 if you do the change base formula. Log of 9, close it up, divide by log of 3, close it up. There's our 2. Okay? Questions on that? So when you turn it into that exponential problem, it's usually pretty easy to do. Okay? Sometimes it gives us a few headaches, but overall, pretty easy. All right, let's go over homework answers. Okay, we did the odd ones, right? All right, so number 1 there was -1. Number 3 is 7. Number 5 is 1.771. If you had 1.8, that'd be okay. Number 7 is -5/3, which is -1.6 repeating. Number 9 is 0.255. Did I have you do 11? It's x equals 0.173. Did we do okay on the number 11? Since the base is e, I probably would have used natural log of both sides. Whenever I see that e for a base, because what is the base for natural log? E, right? So the first thing I would have done on that one, let's look at that one. Like 9 and 11, I would have taken, for 9, I would have divided by 5 first. Get that 5 out of there so it doesn't mess with you. Okay? So I got 7 to the 5x equals 12. Then I would do that problem. Take the log of both sides. Okay? For this one, all right, I would subtract the 9. I'd get this e to the 4x alone. All right? So I'd get 3. Let's move this down here. So I have 3e to the 4x. And what's 15 minus 9? 6. Then I take the 3 over. How do I take the 3 over? Divide it, right? We didn't have one like this yesterday, so that's why I'm going over this one with you. Now I would go from there. But I would take natural log, okay? Because that base is E. And then what happens when I have a natural log and an E? They cancel, so it just gives me that 4x. And then I put natural log of 2 in my calculator. Well, I thought I hit my calculator. Why aren't you coming? There you go. So natural log, that's this button, ln, of 2. And I get that 0.6931. Well, we're going 3 decimal places, aren't we? 693. And then divide by 4. So divided by 4, 0.173. That's how I would do that one. That's what I told you it was, right? Okay, so that was a little different one. Okay. So if you have a number in front here, times, I'd move that over first for number 9, and then do it. Take the log of both sides. When I see this E part, I try to get that E to the 4x isolated first. So like number 12 here, I'd add 7 divided by 2 first, just to get that E, and that makes it real easy. Okay? Any questions on any others? 1, 3, 5, 7, 9, 11. We okay? All right, 17 to 23. When it's natural log of something equals natural log of something, I can just drop those, remember? So you just write 4x minus 12 equals x. And what's it come out to be, like 4 or something like that? Where are we at? Number 17? Yeah, x is 4. 19 is 3. 21 is 6. And 23 is 1. All right, any of those you'd like me to go over with you? This one also, I could just drop those and write 3x minus 4 equals 5. This one I got to write 2 to the 5th equals 4x plus 8. And here it's just drop the logs. So x minus, or 12x minus 9 equals 3x. Okay? Questions? AJ, quit causing problems, please. You guys got questions? I kind of went fast on those, but I think you guys got this. Okay. Today there's a couple problems we're going to show you that are a little bit more work to it. So we're going to do what? Exponentials, we take the log of both sides. The logarithmic we write in exponential form, right? Okay, so that's basically what we're doing. Nothing new today. All right, what we're going to do to both sides here. Let's go through this together. Tell me what to do first. Take the log, right? So what happens to those exponents? They come out front. So it looks like this. So we got everything on the same level. We took those exponents out of the exponent level and moved them down to the main level. Taylor, now what? Thank you. That is correct. I always like to go take the log on the left over to the log on the right. So I just have x on the left. I still got this x plus 3. And then I'm going to get a number here that I'm going to have to distribute. All right? So log 1 divided by 9 for 1/9. Close it up. Divided by log 81. Negative 1/2. So I have to distribute that. Okay, so I've got x equals negative 1/2 x minus 1 1/2. All right, I'm gonna add the 0.5x or the half x. So what's 1x plus a half x? 1.5x, right? And then I divide by 1.5. What do we get? 1. Close. Not 1. -1, yeah. Okay. So 81 to the -1 should equal 1/9 to the -1 plus 3, which is a 2, right? Let's see if that works. We'll do both of those. 81 to the -1 power and 1/9. Oops, forgot my 9. Squared. Those the same answers? Yeah, we got the right answer. Make sense? Wolfie? Okay. About here? This is much easier. Why? When I take the log, where's that x go? Out front. So all I end up doing is dividing log of 8 by log of 3, right? And we're done. Mason, what do you get when you do that? Thank you. 1.893. Those are really easy when they're like that, right? So far, so good? All right, what are we going to do here? Just drop the logs, right? We good on that one? All right, we won't go through that one. You guys are good on that one. What about this one? 3 to the 4th equals, then we go from there, right? 3 to the 4th, I think, is 81. So this is going to end up being 9, right? Because I add 9, 90, divide by 10, get 9, right? So those are easy. We got these down? Vince, wake up. This is the base, that's the exponent. And then equals whatever's next to the log. Okay? Stuff we did last week. You did good on that quiz. Nothing new. You just forgot that we did that. Here's the ones that are a little bit tough. What's the rule? I got to condense that one on the left. Caitlin, how do I condense log of 2x plus log of x minus 5? Make it one log. Put them together. It's addition. Well, I end up distributing, yeah. So, but when I distribute, I turn it into from addition to, when I put them together. Yeah, multiplication. All right, so we have to do condensing first. But that's nothing new. We've learned how to do that, right? We did that the other day. Okay? And she said distribute, which is right. So we're distributing the 2x. So we get 2x squared minus 10x. Now what? What have we been doing with these? Turn it into a exponential. Cole, what's my base?
10.
Yeah, it's 10. When it's not written, the base is 10, right? So this equals 10 squared, right? I just put the 10 to the second on the right instead of left like we've been doing. What is 10 squared? 100. Now, we've got what type of equation here now? We haven't done them for a while, but we've done lots of these. What do we call that when it's an x squared? Quadratic, yeah. This is a quadratic equation. So when we were solving these, we had to set it equal to what? 0, right? So I got to bring that 100 over. So that's all. It's nothing new for you guys. It's just we haven't done one of these for a while. I like to try to factor, and I always look for a GCF. What's the GCF? 2, right? If I take the 2 out, I get x squared minus 5x minus 50. Are there factors of negative 50 that add up to negative 5? Good, Vince. 10 and 1. Was that you, Vince?
Nope.
Oh, sorry. Is that you, Kevin? Okay, go ahead, Kevin.
No, -10 plus.
Good. Negative 10 and positive 5.
Joking.
What are my 2 answers, Vince?
And -5.
Very good.
Oh boy.
See, you remember stuff. Gotta give yourself more credit. Too hard on yourself. Now, we have to check. Questions out that's coming back to you guys? We could always use a quadratic formula if you wanted. If you don't like factoring, you could do quadratic formula and get the same 2 answers. Now, we have to check these though, okay? Because sometimes they don't all work, right? You can't take the log of a negative. Let's say I try to do log of negative 5. Watch what happens. Right, get an error. It's non-real, okay? So, when I substitute in, I'm just basically, what were the 2 answers? 10 and negative 5, right? When I put a 10 there and a 10 here, I still got a positive number, right? But when I put negative 5 here, I get log of negative 10 for both of those, right? Can't do that. Can't find the log of a negative. So our our negative 5 answer is not a good answer. Okay? That's the same thing. How do I condense those? That's their addition. So when I condense it, I make it multiplication. What if this was subtraction? What would I have done? I would make it a fraction, right? So I think I would have liked that to be just so we would have done one. But you guys know that you can write it as a fraction then, right? So this would be x plus 12 times x equals 3. And remember, it's still log base 4. Well, now I can distribute like we did before. I'd get x squared plus 12x, and then equals 4 to the 3rd, right? When we write it exponentially. Now that 4 to the 3rd is 64, right? So I'm going to bring it over so I have it equal to 0. So that equals 64 there, so I'm going to subtract 64. So it looks like that. And factors of 12 that, not factors of 12, factors of negative 64 that add up to 12 are 16 times negative 4 is negative 64, and 16 minus 4 is 12. So what are my 2 answers? Negative 16 and 4. All right, let's go back up here. If I put negative 16 there, is that a positive or negative answer? Negative, so that's not a good answer, right? So if I put a 4 there, I got a 16, a positive, and a 4, so it works. So those are the extra different ones from yesterday. Yes. 4 cubed, right? We put those together. When we change it from a log form to exponential, whatever comes after the log equals the base to that power. Okay? Sydney, is this helping? No? Well, I can't help you then.
Come on, your phone over here.
Yep, exactly.
So, we all know it.
Yes.
You do a first grader today?